Hi everyone, this is Michael. I'm from Juniper AI security team. So today I'm going to talk about the security for the next decade, the AI-driven security. So if you say that the Google, Amazon, right, they are the leader of the AI research right now. Juniper is the leader of the AI ops. Right? We recently recognized by the Gartner Magic Quadrant chart as a leader in terms of the AI ops. And today I'm going to talk more about from the security perspective all the unique features that is from the Juniper networks. For example, the encrypted traffic analysis, the proactive attacker block, the self-mitigation networks. So I'm going to explain the features and the details in different scenarios, right, to make sure that it suits all different kind of need. The first one is the internet facing, right? The second one is the intranet or WAN face, the kind of air gap environment. So in terms of the first one, we have encrypted traffic analysis without using the decryption, without using the SSL proxy. Because we know that the SSL proxy is really like resource heavy, it's really expensive as well, right? And it's like very impactful to the performance. So for example, once you turn on the SSL proxy, just to inspect the encrypted traffic like HTTPS, you're going to lose at least 50% of the performance. Why we need to do that? So that's why we come up with a solution that allows you to perform the encrypted traffic analysis, like HTTPS, without decrypting the traffic. And we have another feature, which is called the proactive attackers block. So over here, you have a distributed setup across the world. And one SRS firewall is detecting attacker's IP. They're going to spread across, right? Send the attacker's IP to the rest of devices immediately. So the rest of devices is going to put up an ACL against the particular IP addresses. So no attackers will be able to access the rest of devices because the IP reachability has been blocked. So this is the second feature of the proactive IP block. And these two features are leveraging on our cloud-based AI engine. So that requires an internet connectivity. Let's deep dive into the first feature, which is the encrypted traffic analysis, how it works, when it makes sense, right? So basically, the payload is always encrypted. We don't have those visibilities unless I have the key, but it's not necessary. Why? Because the other part of the traffic is the header information, is the certificate information, is the traffic pattern. Right? So we're going to record down the metadata. For example, the header information, what cipher suit you're going to use. Right? You're going to use the AES-256, SHA-256, or RSA over the human, we're going to record down. You're going to use this kind of certificate, we're going to record down. And we're going to record down your traffic pattern. Right? We know exactly what you're doing. And we compile the data and compress it into a very small file streamed to the cloud for the analysis. And on the cloud, what we have? Right, we have AI machine learning-based analysis engine to detect the zero-day attack, to detect the malicious communication. Well, we can do that. The Juniper has been in the security market for more than 20 years. We have our own renowned threat lab, which is called the Juniper Threat Lab. We have samples of hundreds of millions of malware and malicious files. And based on that, we train our AI machine learning engine so that it can detect intelligently of those like metadata of the traffic pattern that is sent by the SRX without decrypting the traffic. And the AI machine learning engine is going to come back with a verdict telling you that, hey, this is malicious. No, this is benign, right? So this is how it works. And we have another revolutionary feature is if you integrate the Juniper security firewall and the Juniper AP together, because we are not just a security provider, we are an end-to-end network solution provider. So we can provide to you is we're able to allow you to visualize the attacked user, the compromised user, the infected user on the map, know where he is right now. You can just simply track it down, right? Kick the door open and say, hey, stop doing anything, right? You are currently attacked, right? Please like lock down your Windows machine or whatever, right? So the analysis tool is going to tell you what happened to the particular user and show you all the details of the particular user. And based on that information, you can decide whether I'm going to block the particular user immediately or just quarantine the user. And in the air gap environment, which suits perfectly for the government, for the bank, that kind of a use case, right? we have the solution for you. We have not just on-prem, the AI, and also the cloud AI, right? So here is the on-prem AI. So we have the SRS firewall that is facing the intranet or the WAN. So there were two different kinds of malicious file. One is known, the other one is unknown, right? So for known file, very straightforward, right? We just stream the log to the JSA or Juniper Secure Analytics, which is the Juniper version of the SIEM. Or we're going to like send the unknown file to what? To the Juniper ATP, right? Which is our on-prem ATP scanning engine that is leveraging on the AI and machine learning for the zero-day attack scanning. And of course, you can have your own like CrowdStrike or Carbon Black, those are ample protection solutions. But without internet connectivity, they can't do nothing with a known file. They don't have the scanning engine in place. So they still have to send back the file to Juniper ATP for the scanning. So we're going to come back with the infected user profile, which is the infected user IP. And this is how we make a difference in the market. We're going to translate the IP to the MAC address by using the very unique the Juniper Security Controller. Why we need to do that? You must be asking, why is it necessary? Because from the network perspective, from the access switch layer perspective, from the AP perspective, it has no visibilities of the IP. If you are to block just simply on IP, like all other vendors do, it's going to be useless. And nowadays, the malware is going to be very intelligent. It can do self-replication over the LAN, over the access switch, over the access point, right? And attackers, they're very smart. They hop from one device to another to gain elevated access. And there's an attack called lateral movement over layer 2 devices. So simple IP block will not be enough. You must block both IP on the firewall layer, on the core switch layer, and the MAC address of the particular infected user on the access switch layer. And you'll be arguing, hey, I have the ample protection solutions, right? I should be having a peace of mind. I will say, yes, it's good enough, but not 100% secure. Why? Here, the tweets, right? The tweets in 2017 already proved to you that the Carbon Black or other kinds of platform-based ample protection solutions can be easily bypassed as long as you gain certain level of access. For example, you're using Linux. You get the root access, you can do whatever to the loading, the booting process. It can be easily bypassed. It can be easily defaced. So you'll say it's secure, it's helpful. Yes, somehow. However, it's not 100%. So that's why we come up with a solution by leveraging the automated, the layer 2 switch AP MAC address-based host block for zero-day attack for malicious file. And it is unique to Juniper networks. And next, since we're talking about AI, so I'm going to explain to you in details how it analyzes the file, leverage the AI machine learning engine. So here, imagine we have the AI machine learning engine receiving the file, right, from the SRS firewall. And what we're going to do is, first of all, do the cache lookup to see whether the file has been scanned before. If no, then we're going to perform the standard antivirus scanning, but over here we're going to use multiple antivirus scanning engine, more than 5. And we're going to perform the AI-based static analysis to detect whether there's a malicious patterns to the file. So for example, it's a Word document. And once you open up the Word document, it's trying to query the DNS server, right? It's very suspicious. And for example, the Word document only has one liner of content. It's very suspicious, right? And the Word document has an embedded executable file. Very suspicious, highly suspicious. I'm going to block it immediately. Last but not least, we have the last resort protection, which is to run the application in the sandboxing, for example, the Windows and Linux, to see that, to detect that whether there's a malicious behavior happening. So this is how it works. And last but not least, I would like to highlight the key benefits of our Juniper Connected Security. Imagine a threat is detected, your environment is compromised. In the old days, right, the network team and the security team, they will be pointing finger at each other, saying, that's not my issue, you should be blocking on the firewall layer. No, not my issue, you should be like updating your patches on the switches. So they blame each other until like a few days later, this argument can be settled, that they come up with a resolution, but that is too late. So with that, we come up with the Juniper Connected Security Solution that automates the threat mitigation in real time, which means that whenever a threat is detected, we're going to perform the block on the firewall layer, on the core switch layer, on the access layer, and also on the AP layer. Why? Why we can do that? First of all, we have a unique Juniper security controller, as I mentioned earlier. And secondly, remember, Juniper is not just a security provider for 20 years. We're also a network solution provider for 20 years. So that's why we have the capability to perform the self-remediation, self-mitigation towards the threat to better secure your environment. So that's all for my presentation. Thank you very much.